Today we're going to take a look at section 1.3 and we're going to start talking about fractions, and everybody said, yay! No? You guys don't love fractions?
Super.
Okay, well we're going to start talking about them anyway. Fractions are really important. They're actually easier to use in most of mathematics than decimals. And I know that seems sort of like a strange thing to say because we don't feel quite as comfortable with them, but for computational purposes, they're quite more user-friendly. And so we're going to take a look at 3 ways to decide if fractions are equivalent. This is a test of my memory, right? Okay, the first way to decide if fractions are equivalent, well, I still got a color on the class, is to cross multiply. So if you have A over B, if it's in fact equal to C over D, this is true if and only if AD is equal to BC. So if I can multiply across the diagonals and get the same value, then the fractions were equal to begin with. Okay. The nice thing about this is that it's usually pretty straightforward to do. If the numbers get large, it's not necessarily the prettiest thing to do sometimes, but it's usually not too bad. The second option is to find a common denominator. So the easiest way to find just any common denominator is to simply multiply your denominators together. So for instance, again, if you have A over B and C over D, you just multiply them by each other's denominator, no matter what they are, and then you're able to make a comparison, like actually able to compare, not just decide if they're equal. The third option is to find a least common denominator. And instead of using some arbitrary values, let me show you an example of that. Let's say we wanted to see if 1/2 was the same as 2/4. Okay, obviously y'all know it is. So finding any common denominator would simply be multiplying the 2 by 4 and the 4 by 2, and the same thing for their numerator. But you can actually find a least common denominator by simply changing the 2 to a 4 by multiplying it by 2. So now they're both 4s. So sometimes common denominators is sort of like an overkill, but sometimes least common denominators ends up feeling like you have to do too much deciding between things, what I'm going to do. So those are 3 different ways to decide if fractions are equivalent. So we're going to look at some examples. The first example is reducing to simplest form. So as we're reducing to simplest form, what we're looking for is we're looking for values that the numerator and the denominator are both divisible by. So when we take 36 over 102, there are maybe several different things that jump into your mind as possibilities, but at the very least, I hope you look at that and say they're both even, right? So even if you aren't sure if it's the biggest thing that divides them both, it's something that divides them both, so we could start there if we weren't sure what else to do next. So what is 36 divided by 2? 18 is correct. And how about 102 divided by 2? 51. Okay, so now look at them and you say, well, they're at least not both even, right? They're not both divisible by 2. So you might look at things that 18 is definitely divisible by because it's a smaller number that's more familiar to you. So what's another number that would divide 18? 3. So let's see if if 3 will divide the 51. So you can check it either with your calculator or divide it out. Does 3 go into 51? It does. So have you ever learned the trick to know if something's divisible by 3? No. I can tell you a trick. It's very cool. So let's take a look at the 5 and the 1. What's 5 plus 1? Is 6 divisible by 3? Yeah. And so is 51. Actually works for 9 as well. So if the two numbers added together are divisible by 9, then the original digits are divisible by 9. So it's kind of a cool trick for 3s and 9s. So this will divide, but we actually have to do the division now, either again with your calculator or by hand. It's not a difficult one to do by hand, so I'll just do it. So 3 goes into 21 7 times, so we've got 17, right? So the division on top by 3, the division on bottom by 3, I already did the bottom at 17. What's my numerator? 6. 17's prime, so we can't go any further. If we could go further, we would, but this one is actually finished at that point. So that's reducing or simplifying fractions. Even if you're working with them to add or subtract, multiply or divide, it's often easier to work with a reduced fraction to start with. So sometimes it's helpful just to reduce the fractions before you get going. The next example is wanting us to fill in the blank to create equivalent fractions. So what I want us to recognize is how we actually have adjusted or changed the denominator so that we can make the corresponding change to the numerator. So how do I change my denominator from 9 to get to 27? Yeah, multiply by 3, yeah. So her people say 3, and you're right, it's multiply by 3. So if I do that to the denominator, I also have to do the same thing to the numerator. So what is 6 times 3? 18. So I'm filling in the blank on this one, it's just the number 18 that goes there. Fraction multiplication. So there's a couple of different ways that you can multiply fractions. The first option is that you can reduce or simplify if you prefer. Within the fractions and across diagonals. And after you do that, you would multiply the numerators and multiply the denominators. So that's one option. That's the option I usually go with. Benefit to this option is it keeps the values typically smaller. Or, instead, you can actually do the multiplication parts first. So you multiply the numerators and multiply the denominators first. And then at the end, you can reduce the fraction or simplify the fraction. I'll pop back over here in just a second. All right, so let's do some examples. On the first one, I'm going to go ahead and do it both ways, the two different options that I just gave you. When you're doing your homework or anything else later, I don't care which way you do it. It does not matter to me in the slightest. So pick your favorite and go with it. But I'd like to make sure you see me do both options so that maybe you have an educated decision to make about why you might choose one over the other, which one appeals to you more. So option number 1 is to take a look at the fractions themselves and see if they reduce. So 4 over 9 does not reduce, right? 4 and 9 don't have anything in common. 15 and 22 do not either. But if we look across the diagonals, they will. So the 4 and the 22 are both divisible by 2. So 4 divided by 2 is 2. 22 divided by 2 is 11. The other diagonal, 9 and 15. 3. Yeah, they're both divisible by 3. So 15 divided by 3 is 5, and 9 divided by 3 is 3. The wonderful thing that happens if we reduce right now is that once I do my multiplication here, I know my answer will already be in reduced form because I've done all the reducing at the beginning. So 2 times 5 is 10. 3 times 11 is 33. Okay, so that's option number 1 from the previous slide. Let's do 4/9 times 15 over 22. All right, so if we go with the second option, we multiply straight across the top, straight across the bottom. So what is 4 times 15? Y'all know?
60.
It is 60. Good. How about 9 times 22?
190.
100 what?
98.
98. Sorry. Okay. So at this point, we have to do the reducing. And again, we might look at this and not know exactly where we want to divide by, but we should at least recognize that it's even. If you recognize it's divisible by something bigger, by all means use that something bigger. But at the very least, we know they're both even. And therefore, we can divide by 2. So this would be 30 over 99. And you probably recognize that one as being both divisible by 3, right? 30 and 99. And of course, we end up with the same 10 over 33. So it's just an adjustment in the order of what I'm doing. Doesn't change anything really. I like the first option because I like keeping my digits smaller. Okay, so I'm going to do the option that I prefer on number 2. If you would prefer to do it the way I just did, where you multiply straight across and then reduce, by all means, feel free to do that. But if we take a look across diagonals, 2 and 10 both have a 2 in common. So 2 divided by 2 is 1, and 10 divided by 2 is 5. What do 21 and 9 both have in common? 3. I promise it's not always 3s and 2s. It's just the numbers I picked, okay? So 9 divided by 3 is 3. 21 divided by 3 is 7. And then multiplying across, I have 3 over 35. Is that red visible like to everybody from the back, or do I need to change the color? It's okay. All right. Any questions on either of those? All right, let's keep going. Number 3 looks a little different. What is it about 3 that looks different? Yeah, the 4 is a whole number, right? So let's change it into something that looks like fraction. How could I write the number 4 as a fraction?
4 over 1.
Yeah, so 6 over 7, 4 over 1. That's our easiest way to rewrite it. There's other ways you could, but that's our easiest. So on this one, if you look across the diagonals or within the individual fractions, what do you notice?
You can't reduce.
You can't reduce. So we kind of just eliminated one of the 3 steps, right? That's great. Easier to do. I have 24 over 7 when I multiply across. So sometimes you won't have any reducing. That's fine. I don't know if I've said it in this class because at this point some of the material I'm teaching is overlapping in about 3 of my classes. But in this particular point in what we're working on, unless it starts out as a mixed number, we're not changing it to a mixed number. So this had 6 over 7 and it had a whole number 4. but 24 over 7 is a perfectly reasonable answer. If you really want to write it in an improper or change the improper fraction to a mixed number, it would be 3 3/7, but there is absolutely no expectation right now that that's what we're doing. We will talk about that later, but that's not what we're doing right now, okay? All right, we're going to talk about reciprocals. A reciprocal is the multiplicative inverse of a value. And for example, if we have the value a over b, then the reciprocal is b over a. And by definition, the reason it is because a over b times b over a equals 1. That's what it means to be a multiplicative inverse. It means that when you multiply it by its multiplicative inverse, you get back the multiplicative identity 1. So we're going to look at a few examples. 4 over 7 is a reciprocal of what? What would I do for its reciprocal? 7 over 4. And I want to make sure that you understand the why. The reason it's true is because 4 over 7 times 7 over 4 is what? 1. That's why. It's not because I flipped it upside down. I know that's what you did, but that's not what makes it a reciprocal. What makes it the reciprocal is that when you multiply it by the other value, you get back 1. 3. What is 3 the reciprocal of? 1 over 3. You're right. 1/3. Why? Well, because 3 times 1/3 is 1. Yeah, I know. How about 3/5? 5/3. You bet. Why? You guys annoyed yet? Because 3/5 times 5/3. Is somebody giving me a wrong answer? On purpose, I can just tell right there. You said 2, and then I wrote a 2. Look at that. Power of suggestion. 3/5 times 5/3 is 1, not 2. That's not going to work. We'll leave it there. So when we take a look at fraction division, so we're talking about multiplication and division of fractions in this section. Next time we'll talk about addition and subtraction. Multiplication and division is easier. When we write 8 divided by 2, like this, another way of writing that in fractional form is 8 divided by 2 is a fraction. But, I'm sorry, not 2, 4. 8 divided by 4 is a fraction. But 8 divided by 4 is the same thing as 8 times 1 over 4. You can imagine taking, especially this form, if it's nice to see that we have 8 times the 1 over 4, where the 4 is coming from the denominator to here, right? So when we're looking at division, we're actually looking at multiplication by the reciprocal, which is why we talked about the reciprocal in the previous slide. So when we're looking then at some examples and we're asked to simply divide, this says 2/3, literally it says 2/3 divided by 6. So it's fine to write it that way, but it doesn't look very friendly. And the reason it doesn't is because there's 2 division statements there written differently. One of them is written as a fraction, right? 2 divided by 3. And the other one's written as the division sign and then a 6. That's not nice notation, and it doesn't lend itself to convenient methods for doing this. So instead of writing divided by 6, right, just like over here the divided by 4, we're going to write it as multiplication by the reciprocal. So that same number we had before, the 2/3, is going to be multiplied. What's the reciprocal of 6? 1 over 6. And then we're back to being able to use the same things we were early on, which is to see about multiplication. Straight across the top, straight across the bottom, and reduce, or reduce and then multiply. So I'm going to reduce the 2 and the 6, which gives me 1 and 3. And then I'm going to multiply. Across the top I get a 1, and across the bottom I get a 9. So 2/3 divided by 6 is 1/9. Now you can imagine what that sort of looks like. We're going to talk more next time about sort of imagery of fractions. But if you had 2/3 of a pizza, can you picture it? You guys have eaten enough pizza in your life. You should be able to picture what 2/3 of a pizza roughly looks like. So if you took this pizza, oh goodness gracious, that's not too bad. And you took 2/3 of it, it would look something like, give or take this. And we'd have this much of it. And we're dividing that into 6 pieces. 1, 2, 3, 4, 5, 6. The size of the pieces actually become a 1/9 of the size of the whole pie. That's what's happening. Okay? And if it's hard to picture here, you could divide the other one into 3 pieces as well to count it. There's 9 pieces now, 1/9 of it. So that's what's happening when we're looking at dividing here. The next one is 3/10 divided by 3/4. In some ways, that's even less friendly because now I have 2 fractions with a division sign between them. So instead of writing it as division, I'll change it to multiplication. And what will I be multiplying by? 4/3. So looking across my diagonals, these 3's flat out cancel just completely. The 10 and the 4 are both reducing by 2, so they divide by 2. And I end up getting across the top of 2 and across the bottom 5. So this is a answer of 2/5. Any questions on any of those? All right, so this assignment has homework 3 attached to it.